Hello everyone, today we will be solving question number 29 from GATE 2019 chemistry paper. The question is, in the EPR spectrum of a methyl radical, the number of lines and their relative intensities respectively are option number A, 1 and 1, option number B, 3 and 1 is to 2 is to 1, option number C, 4 and 1 is to 2 is to 2 is to 1, option number D, 4 and 1 is to 3 is to 3 is to 1. So first of all, EPR stands for electron paramagnetic resonance, and the conditions for being EPR active is the molecule must have at least one unpaired electron and they should have a non-zero spin. That is, I should not be equal to 0. The molecules which are EPR active are radicals, and also let's take transition metals. So in in complexes of transition metals, if we let us take an example of an octahedral complex, which we know that in octahedral crystal field, degenerate d orbitals split into two energy sets, T2G and EG. If we have, let's say, one D1 system, then there is only one electron present in this T2G orbital. That means it is an unpaired electron, and hence this complex will also be EPR active. So wherever there is at least one unpaired electron present, those complexes are EPR active. In this question, we have to write how many lines we will observe for this CH3 radical and their relative intensities. So since this is a radical, therefore it is EPR active. Now to find out the number of lines, we use the same formula as we use for NMR, that is 2Ni plus 1. So here there are 3 hydrogens and the spin value of hydrogen is half. 3 hydrogen, therefore N is equal to 3. So if we put these values in this equation, 2 into 3 into 1 by 2 plus 1, that is 3 plus 1 or 4. So here we will get 4 lines for the CH3 radical. If we look onto the options, the first and second option is has given 1 as the 1 and 3 as the number of lines. So we can cancel out these two options. Among option number C and option number D, now we have to find out the answer by looking onto the relative intensity for these lines. So for I is equal to half, like in NMR spectroscopy, here also we can find out for spin half value atoms where this the relative intensities can be found out by using Pascal's triangle. So Pascal's triangle is this 1, 1, 1, then this 1, and addition of 1 plus 1, 2, then again 1, and here again 1, addition of 1 plus 2, 3, addition of 2 plus 1, 3, 1, here 1, addition of 1 plus 3 is 4, addition of 3 plus 3, 6, and addition of 3 plus 1, 4 again, and here 1. So if we have one line, then it will have intensity 1. If we are having 2 lines, then the relative intensity of those lines will be 1 is to 1. If we have 3 lines, the relative intensity will be 1 is to 2 is to 1. If we have 4 lines, the relative intensity will be 1 is to 3 is to 3 is to 1. If we have 5 lines, the relative intensity will be 1 is to 4 is to 6 is to 4 is to 1. So like that, it will go on. Now in this case, since we are having 4 lines, therefore the relative intensity will be 1 is to 3 is to 3 is to 1. So coming back to the question, which is in the EPR spectrum of a methyl radical, the number of lines and their relative intensities respectively are number of lines is 4 and the relative intensity is 1 is to 3 is to 3 is to 1. So among the given options, option number D is the correct option for question number 29. To know more about this topic, please refer to the Principles and Applications of EPR Spectroscopy by Professor Ranjan Das from Department of Chemical Sciences, TIFR, Mumbai. The link for the lecture is given here. Please go ahead and watch the video. Thank you.